Hi Miss, my name is Maria Camila Coconua, I'm from 8th and this is my evaluation. The first question is what is the binary system, include the terms bit, nibble and byte, and how digital data is represented in a computer. The binary system is a base two-digit systems. The two digits that include is 1 and 0. These include different terms. The term, for example, bit, that is the smallest unit of data in a computer. The term byte, that is the fundamental data drive in a computer and is formed by 8 bits. And a nibble, that is a group of 4 binary digits. And how digital data is represented in a computer? The data represented in a computer is on and off. On is represented by the number 1 and off is represented by the number 0. These sequences form electrical signals that the computer receives so that it can understand the information. I'm going to tell you how to convert a decimal to a binary. Yes? So I choose the number 75. As you can see in binary system we have some digits. These digits are the powers of number 2. 1, 2, 4, 8, 16, 32, 64, and 128. As my number is 65, the number less than 75 is 64. 64 minus 75 minus 64 is 11. The number less than 11 is 8. And 11 minus 8 is 3. And adding 2 and 1 is 3. So in these digits that we have used, that if we add them all together give 75, we're going to put a 1 digit. And in the other ones, we're going to put a 0 digit. This means this is the number, the binary number for this decimal number. Now, I'm going to talk you about the hexadecimal system. The hexadecimal system is a system of 16 base numbers. Yes, the base numbers are going to be 0 to 15. When we are in the numbers 10 to 15, they are represented in letters. As you can see, 10 is A, 11 is B, 12 is C, 13 is D, 14 is C, and 15 is F. So when do we use F? Well, when the number 15 is used. Thank you. Now I'm going to explain you the parity check and the check error, right? So in here we have a sender. The sender we can see in here is 10000011. The parity bit is 1. The receiver is going to be 11100111 and 1. And the parity is even. In here we have a sender that is 1110001. The parity bit is 0. The receiver is 1110000 and 0. And the parity is odd. When it is odd, there's an error. And remember that if you add a digit, the number will change. Now we're going to talk the difference between the types of compressions. There are two types of compressions, lossless and lossy. Yes? The major difference between lossy compression and lossless compression is that the lossy compression produces a close match of the data decompression, whereas lossless create exact original data. There are a lot of difference between them, but this is the principle. Now I'm going to show you some examples. There are different characteristics. For example, in lossless compression, there is not a loss of information. The MSE is equal to 0. The PSNR is going to be infinite. And there are different methods. The rand length encoding, the human codes, arithmetic codes, the dictionary, LZW, and the lossy compressions, some lose information. The MSE is not equal to 0. The PSNR is something more than infinity. There are different methods: improved grayscale, quantization, DPCM, and the transform coding. This is an excellent example: image reconstruction. In lossy, the quality degrades compared to the original image source, while in lossless, quality remains the same with the original image. We're going to talk about hardware and software. Computer hardware is any physical device used in the machine, while the software is the collection of codes installed inside the machine in a hard drive. So the better way to explain this topic is with a daily computer. The hardware are the physical parts, as you can see, the screen, the keyboard, or sometimes the mouse, while the software are the instructions stored right by the hardware. About a logic gate. It is an electronic component used to conduct electricity based on a rule. It has two parts, an output and an input, and there are a lot of them, so I'm going to explain them in a moment. I use a simulator for explaining the logic gates. The inputs are going to be the switches, and the outputs are going to be the things that looks like fun. The first logic gate is and we had to turn the two switches so that it could work. In the OR logic gate, we only had to turn on one. In the NOR, we didn't have to turn on any one, the same as the one for NOT. In the X or R, we had to turn only one on so that it could work. In AND, we didn't have to turn any one, the same as in X NOR. Miss, I hope you like my video. Sorry for my vocabulary errors. I hope you like it, enjoyed listening, and you'll be very happy that a student had learned from you. Thank you.